In 1859, Earth was hit by the most powerful solar storm in recorded history. Telegraph systems caught fire, operators were electrocuted, auroras appeared over Cuba, Hawaii, and Colombia. And if a storm that powerful hit Earth today, modern civilization could collapse within weeks. The terrifying part is this: it will happen again, because the sun is not calm. It never was. Right now, 93 million miles away, the sun is constantly exploding. Every second, it releases more energy than humanity has used in all of recorded history. Most of that energy never reaches us, but sometimes the sun erupts, and when it does, it can launch billions of tons of superheated plasma directly into space. These eruptions are called coronal mass ejections, CMEs. Imagine tearing a piece of the sun itself into space, a cloud of charged particles larger than Earth, traveling millions of miles per hour. If that cloud misses Earth, nothing happens. But if Earth is in the way, the consequences can be catastrophic. To understand why, you first need to understand how fragile modern civilization really is. Because civilization is not built on concrete, it's built on electricity. Electricity powers our hospitals, our banks, our satellites, our water systems, our communications, our transportation, our food supply. Almost every system that keeps billions of people alive depends on one thing: a stable electrical grid. And that's exactly what a major solar storm attacks. When a coronal mass ejection hits Earth, it slams into our planet's magnetic field. Normally, Earth's magnetosphere protects us from charged particles coming from the sun. But during a major CME, the magnetic field becomes violently disturbed. It shakes, twists, compresses, and as it moves, it generates powerful electrical currents across the planet. These are called geomagnetically induced currents, GIs, and they travel directly into power grids. The problem is transformers. High voltage transformers are the backbone of modern electricity networks. They're designed for stable electrical flow, not massive surges from space. When a severe geomagnetic storm hits, these transformers overheat. Their copper windings melt, insulation burns, internal components fail permanently, and once they fail, entire regions lose power, not for hours, not for days, potentially for months or years. Because these transformers are not sitting in warehouses waiting to be installed, many are custom built. Some weigh over 400 tons. And manufacturing replacements can take up to 2 years. Now imagine that happening across multiple countries at the same time. That's the danger. And we've already seen smaller versions of it happen. In 1989, a geomagnetic storm hit Quebec, Canada. Within 90 seconds, the entire Hydro-Quebec power grid collapsed. 6 million people lost electricity. Not because of war, not because of terrorism, because of the sun. And that storm was significantly weaker than the Carrington Event of 1859. The Carrington Event remains the largest solar storm ever recorded. It began on September 1st, 1859, when British astronomer Richard Carrington observed a massive white light solar flare. 17 hours later, the CME struck Earth. The skies turned red across the planet. Auroras appeared near the equator. Telegraph systems failed worldwide. Some operators reported sparks shooting from their equipment. Others said their systems continued operating even after disconnecting power supplies. The storm itself was generating electricity inside the wires. That was in 1859. Before satellite, before computers, before the internet, before modern civilization became completely dependent on electronics. If the same event happened today, the consequences would be unimaginable. Satellites could fail almost immediately. GPS systems could collapse. Air traffic control systems could become unreliable. Financial networks could stop processing transactions. Internet infrastructure could break down. Undersea communication cables could be damaged by induced currents. Cell towers would fail once backup generators ran out of fuel, and most people wouldn't understand what was happening until it was already too late. The first 24 hours would feel confusing. Phones stop working. Internet disappears. Power grids fail region by region. Governments issue emergency alerts. Then the panic begins. Gas stations stop pumping fuel because pumps require electricity. ATMs fail. Credit cards stop processing. Supply trucks stop moving. Within days, supermarket shelves begin emptying. Water systems become unstable. Hospitals switch to backup generators, and backup generators require fuel, which becomes harder and harder to transport. Within 1 week, major cities begin facing severe shortages: food, medicine, clean water. Emergency services become overwhelmed. Police departments struggle to communicate. Traffic systems fail. Airports shut down. Ports stop operating normally, and the economy enters free fall. Stock markets close. Banks suspend services. Digital transactions disappear. For most people, modern life simply stops functioning. And here's what makes this scenario so dangerous. There may be very little warning. Scientists can observe solar flares and CMEs using satellites like SOHO and the Solar Dynamics Observatory, but depending on the speed of the CME, Earth might only receive between 15 hours and 2 days of warning. That's almost nothing, especially for protecting global infrastructure. Some transformers can be disconnected in advance. Some satellites can enter safe mode. Power companies can reduce load on grids. But if the storm is strong enough, damage may still occur. And eventually, another major solar storm will happen. This isn't speculation, it's statistics. The sun operates in cycles, approximately every 11 years. Solar activity rises and falls. We are currently in solar cycle 25, and scientists believe solar activity is approaching its peak. That doesn't guarantee a catastrophic storm, but it increases the probability. In fact, in 2012, Earth narrowly avoided disaster. A massive CME erupted from the sun in July of that year. It crossed Earth's orbit, but Earth had moved out of the way just 9 days earlier. NASA scientists later concluded that if the CME had hit Earth directly, the damage could have reached trillions of dollars. Potentially the largest technological disaster in human history, and most people never even heard about it, because we got lucky. That's the uncomfortable truth about solar storms. Our survival depends partly on luck. Luck that the sun erupts in the wrong direction. Luck that Earth isn't in the way. Luck that the storm isn't just slightly stronger. And eventually, luck runs out. Now, to be clear, a solar storm would not wipe out humanity overnight. This is not a Hollywood apocalypse where cities explode instantly. The real danger is slower. Civilizational collapse. Through infrastructure failure, modern society depends on constant electricity. Without it, supply chains fail. Without supply chains, cities become fragile very quickly. Most urban areas only store a few days of food. Most hospitals rely on backup power that eventually runs out. Most people have no long-term emergency supplies, and once communication systems fail, fear spreads faster than information. That's when societies become unstable. The terrifying part is that we already know how vulnerable we are. The U.S. government has studied this scenario for years, so have European agencies. So have power companies. Experts have repeatedly warned that electrical grids need stronger protection against geomagnetic storms. Some improvements have been made, but not enough, because hardening national infrastructure is expensive. And preparing for a disaster that might happen once every century is politically difficult. Until it actually happens, then suddenly, preparation matters more than anything else. So what can individuals do? Honestly, not much can stop a solar storm itself, but preparation still matters. Battery-powered radios, stored clean water, non-perishable food, backup medications, flashlights, portable solar chargers, cash, because if electronic payment systems fail, physical money becomes important again, and perhaps, most importantly, community. In long-term disasters, survival often depends less on technology and more on people, neighbors helping neighbors, communities sharing resources, local coordination replacing systems that no longer function, because during a prolonged blackout, your community may become your only safety net. And here's the deeper reality behind all of this. Human civilization feels permanent, but it's not. For thousands of years, humanity lived without electricity. Then, in just over 1 century, we built a civilization completely dependent on it. A civilization connected by invisible currents moving through wires across continents. And all of it exists beneath a star capable of damaging that civilization with a single eruption. The sun does not hate us. It doesn't care about us. It simply follows the laws of physics, fusion, magnetism, plasma, violence on a scale the human brain struggles to understand. Most of the time, Earth's magnetic field protects us. Most of the time, space is survivable. Most of the time, the sun misses, but not always. In 1859, it hit. In 2012, we escaped by 9 days. The next time, we don't know, and that's what makes coronal mass ejections so dangerous. Not because they are rare, but because eventually, one will arrive at exactly the wrong moment, and when it does, humanity will discover how fragile modern civilization really is.